Ian Cousins, and I'm a professor at Stockholm University. I'm an environmental chemist, and I've been studying PFAS for over 20 years. I'm going to talk about polytetrafluoroethylene from a life cycle perspective and talk a little bit about the essential use concept. Well, we heard about some of the very well-known uses of PFAS from Lisa, but what actually are PFAS used in more generally? And we didn't actually know the answer to that either. So we, Juliana Gluger, who's also in this meeting, I noticed, and myself and others conducted a review of all of the uses of PFAS in society. And we found over 200 different uses of PFAS. And as you can see from this graph here, the light blue bars show the uses of polymeric PFAS. And in fact, most of these are dominated by fluoropolymers, and PTFE is an example of a fluoropolymeric PFAS. And you can see many of the uses of PFAS are these fluoropolymers. And actually, I noticed that the use of fluoropolymers in lubricants and greases is one of the major uses of polymeric PFAS. And then also we uncovered in this overview of all of the different uses, we also uncovered lots of uses that we didn't know about. Obviously, someone knew about them, like the people who make these products, but they were also used in things like ammunition, climbing ropes, guitar strings, artificial turf, soil remediation, etc., etc. And we found about 1,400 different PFAS were used in these more than 200 uses. So what about fluoropolymers that are used in lubricants, so for example, in bike oils? Well, these can be called fluoroadditives. These are micropowders or which are finely divided low molecular weight PTFE powders. And these are added to a whole range of different consumer products, not just oils or lubricants, but also to plastics, rubbers, paints, printing inks, cosmetics, and others. And we don't know much about this is typical that we don't know much about the contents or the actual concentrations that are used, unless we ask the manufacturers. We usually have to have telephone interviews with them and try and find out a little bit more information. It's very hard to get the information actually otherwise about what's in products. And so we have an idea roughly what the concentration of PTFE would be in bike chain oils, for example. But this again is something we need to find out more information on. And what do they do? Well, they appear to enhance abrasion resistance, reduce coefficient of friction and mechanical wear, for example, of gears, and they also reduce surface contamination. Now, all this information comes from this citation at the bottom, this introduction to fluoropolymers, which has actually been written by the fluorochemical industry. So I presume that it's accurate. And then about 5 years ago, a bunch of us decided that we should have some action, international action on PFAS as a class. And we wrote this statement called the Madrid Statement, which was actually signed by over 200 eminent scientists. And what we asked for is the production and use of all PFAS should be limited. May ask why? Because they're actually a very diverse group of substances. They're liquids, they're gases, they're solids. Some are soluble, some are insoluble, some are volatile, some are involatile, some are bioaccumulative, some are non-bioaccumulative. Some are toxic and some are quite inert. So they are very diverse, but there's one common feature for all of them, and that is they're extremely persistent because of this fully fluorinated carbon chain, which will not break down in nature. They will just last in the environment forever, basically, and that's why they're often called the forever chemicals in the popular press, I guess. So there's concerns regarding this high persistence. So if you have a highly persistent chemical and you continually release it, it will build up in the environment. And ultimately it may build up to a level which causes a threshold, reaches a threshold which could cause a toxic effect. It could be a known effect or an unknown effect. But once you discover that effect, there's little you can do to reverse the contamination in the environment. So you have a problem which you can't do anything about. So that's why we're really worried about extremely persistent chemicals. And at the same time, as Lisa also mentioned, we only really know about the effects of a few of these many thousand substances. We understand the toxic effects of maybe about 4 or 5 quite well. And for the vast majority, we really have no idea what the effects would be. So we're playing a little bit of Russian roulette by continually releasing these extremely persistent substances in the environment. So we called for this restriction on their use. But at the same time, we realized that it's impractical to ban all uses of these substances in one step. You know, they're used for a purpose. They have very useful properties, and in fact, some may serve a critical role for which alternatives do not exist. In other words, they may be essential in society. They may provide essential functions for health or safety, for example. On the other hand, there could be a lot of uses which are non-essential and can be rapidly eliminated. So we thought that, you know, if we could identify these non-essential uses, we could actually rapidly eliminate these without having to worry about further things like comparing their safety with alternatives and so on. And this concept of essentiality actually comes from the Montreal Protocol on substances that deplete the ozone layer, which actually came from quite a long time ago in the 1980s. So this old idea of essential use and the criteria behind essential use was written up in this paper that you see at the bottom, which was published in May in 2019. And it's been very popular to the extent that now it's been written into the European Chemical Strategy, which came out recently. So it's had a large impact on the way the European Union thinks that we should be managing chemicals. Now we can look at, I can just mention a couple of examples of non-essential uses, but I could probably go through quite a long list of them, but I don't have time today. The first one is the use of PFAS in cosmetics, and this includes PTFE, which is added to quite a lot of different products. But PFAS are used in things like hair products, mascara, foundations, face creams, sunblocks, skin creams, lip pencils, etc., etc. And there was a very successful campaign by the Swedish Society for Nature Conservation in Sweden. And my colleagues also contributed to this to analyze the PFAS in a range of different cosmetic products. And actually, it's quite difficult to identify what the technical function is in the cosmetics, and but we can be fairly clear that it's non-essential, because when this campaign occurred, it was quickly announced by many of the major retailers and brands. You see a list here that they would rapidly phase out the use of PFAS in these products. So I think this is an example of a non-essential use. Another example that Lisa mentioned is the use of these fluorinated paraffins, which are used in ski waxes. Now, this, if you want to ski a long way, like people in Sweden like to do this is the Vasaloppet, and they would use fluorinated waxes typically, until recently at least, because it gives you very low friction. And if you have to ski 90 kilometers, and you want to have low friction, of course. But on the other hand, there have always been fluorinated alternatives to non-fluorinated alternatives to fluorinated waxes. Have you ever looked in the store and seen the fluorinated waxes? They usually cost 2 or 3 times as much, but they, for an average skier like me, makes no difference whatsoever to my performance. But for a professional skier, it can take seconds of your time. So it's really, you know, you had a lot of use in international competitions. But there are alternatives, and these alternatives work fine. And most people, average skiers like myself, would use these non-fluorinated waxes in everyday usage. So there's no reason to use this. This is another example of non-essential use. And these have been already phased out, as Lisa mentioned. So I could go on and mention quite a few of these non-essential uses, like in food contact materials and so on, that we have also identified in our paper. But I want to talk about the use of PTFE in lubricants. And the problem with this, as I see it, is it's an open use. So the PTFE that's used in this product will be released to the environment during usage. Now, the result will be a very persistent microplastic, which will never degrade, will be released to the environment. Is it toxic? Well, the PTFE in itself is actually a pretty inert material. And so really, if there's any toxicity, it's to regarding these very small particles, which we know very little about. The micro and nanoplastic research is an ongoing area of research. So although we haven't identified any obvious effects regarding some of these micro and nanoplastics, it doesn't mean that there aren't any. It's an ongoing area. There could be some toxic impurities in these PTFE micropowders, but they're actually industry have done a lot to reduce the toxic impurities in PTFE products. So they're not particularly toxic. We are releasing, though, a substance which will never degrade in the environment, which I think is a concern. Industry have actually done a big campaign to basically say that PTFE, at least how it's made now, is a polymer of low concern. And there's the paper you see on the bottom is basically saying that it's a polymer of low concern, they say, because the modern PTFE products do not contain impurities. They're not toxic in themselves. They can't be absorbed by the body, they say. And so we shouldn't really be concerned about it. That is really what industry are saying. It's a very important product for them. So we should maybe take it with a pinch of salt. But this is what their campaign is going on about now. But we have also published something recently to say that you shouldn't just focus on the use phase of fluoropolymers. You should really consider the life cycle, because there are many releases of other toxic PFAS which occur during the life cycle. So during the manufacture of PTFE, there are releases. During the product use, the releases are probably less, but also during product disposal, depending on how you treat your PTFE, you can also have releases of toxic chemicals. So this is in a recent paper you'll see in the bottom right. So a little bit about the problems with manufacture. So I don't know if you know, but in the US, Europe, and Japan, historically, PFOA, or its ammonium salt, was used in the manufacture of these fine powder PTFE. And as a result of this manufacture, which occurred from the 1950s until the mid 2000s, a huge amount of PFOA was released into the environment. So this is basically the subject of this movie, Dark Waters, and a lot of lawsuits around the world where all the drinking water around the manufacturing sites has been heavily contaminated with PFOA. But the whole world has been contaminated with PFOA, and all the wildlife in the world have been contaminated with PFOA, and all of us have been contaminated with PFOA. So it's a major scandal. And PFOA is still used in large quantities in China. So if your PTFE comes from China, you are contributing to the release of PFOA into Chinese rivers, into the oceans around China, and globally, contamination of PFOA. Now, most of the manufacturers, or basically all of the manufacturers in the US, Europe, and Japan have now replaced PFOA with fluorinated alternatives in recent years. And there's a couple on the bottom, well-known ones. The bottom one on the bottom left is often known as Genix, and is made by Chemours, which used to be called DuPont. And the one on the bottom right is made by 3M. And you can see they're still PFAS. And so basically what happened was all of the companies that used to make PTFE using PFOA now use different kinds of processing aids in making their PFOA to aid the polymerization. And each company has their own type of polymerization aid. And in the last few years, now we've seen problems with all of these. So in the top left, we have the Genix chemicals contaminating the drinking water around the plants in the Netherlands and also in the US. This is because the substances that now actually have another problem. They're still as persistent as the PFOA, but they're also much more mobile. So they contaminate the drinking water around these plants and stay in the groundwater, which is the drinking water source, basically forever. So we have new problems, and we have new chemicals to sort of study and try and work out their toxicity. And basically, for every case of a replacement, there's basically a horror story of contamination of drinking water and wildlife and human blood around these plants. in recent years. So the fluoropolymers have been in the news for all the wrong reasons, because in the top left, because of the contamination in the Netherlands around the Dordrecht plant, the contamination top right around in North Carolina around the plants there, and then in China for all the PFOA that's now being released into the rivers, where DuPont have now moved their operations, but there are also lots of Chinese companies releasing PFOA into the rivers there. And then on the bottom right, another problem is that as well as these compounds that we can identify that are used as the processing aids, there's also hundreds of other substances that are also released as impurities during the manufacture. And we don't know anything about this, and we're trying to discover what these substances are. So this paper on the bottom right was published in Science and identified hundreds of substances that are in the soils and waters around the plants, which we really don't know anything about. So that's also a big worry. What about the safe disposal of fluoropolymers? Can we recycle them? Well, actually, there's no operational way to recycle the PTFE that's used in consumer products. If it's just like clean PTFE, then it can be recycled, but not the consumer products also mixed in with lots of other things. It's hard to take out the PTFE from all those other things, so it's very hard to recycle it. We could landfill it, but there could be contamination of leachates and also release of microplastics. Incineration may be the most effective way to destroy PFAS, but there's also unknowns regarding when you incinerate, do you form other fluorinated organic byproducts? If the incineration isn't done at a high enough temperature, could you produce fluorinated organic byproducts? And this is an area of ongoing research, so it's also a rather large unknown as to whether we can safely dispose of these chemicals. So what are the conclusions and the way forward as I see it? Well, first of all, we should ask whether PTFE in these oils provides an essential function. I asked myself this before the workshop, and actually I didn't really know the answer to this. They obviously provide a function, as I mentioned on one of the first slides, that they do, provide a lubricating function, but whether this is essential, I think, is in question, because as I've heard, there are other products on the market that can provide the functionality. But is it something you need in high-end performance products? I do not know the answer to that. Maybe the people who work with these products can really provide the answer as to whether it's really important for some high-end performance functions or not. But for sure, PTFE will be released during their use, and as a result, this will never degrade in the environment. And I think, we think this is a problem in itself. We shouldn't be using the environment as a dumping ground, even if we convince ourselves that the chemicals are rather inert now from current knowledge. We cannot just throw it into the environment and just hope for the best. Certainly not in the long term. And we also know that there are environmental releases of all sorts of hazardous PFAS occurring during the PTF life cycle, especially during the manufacture. So when we use PTFE, we might think, for example, even in a PTFE frying pan or something, we might think, oh, well, it's not actually causing any exposure to me. It's no problem for me. So why should I care? But actually, when you use it, when you buy it and everything, you contribute to the environmental releases in the whole life cycle. So you contribute to the releases at the manufacturing sites where lots of people are exposed to these contaminants. And therefore, I think it's unethical to do that. And also both PFAS and microplastics are under enormous regulatory pressure, as we'll hear in the next talk. PFAS, as I say, because of the high persistence, but also microplastics, again, because of the high persistence. People, I think, find it easier to connect with microplastics because it's pollution you can see. And PTFE is a kind of microplastic pollution, whereas the pollution you cannot see, I think people don't connect so well with that. But it's equally a problem if you release chemicals into the environment, like PFOA, which will never ever degrade and just build up in the environment. And we know that there are safe, sustainable, and functional alternatives that apparently exist. So why not use them? That's my presentation. Thank you for your attention.